Hey everyone, Chris from FlipMath here, and I'm going to take you through today's lesson, which is on simultaneous equations, and I've called this one Further Adventures in Simultaneous Equations. This is part of the Mathematical Methods course. The Pure Maths section, although, is suitable for a C1 module for A level as well, if you're catching this. Objectives: solve simultaneous equations with three unknowns. Solve simultaneous equations with one linear and one quadratic. So in the last lesson, the last one we looked at, we had, or I had showed you how to use the elimination method, most popular, and also the substitution method to solve simultaneous equations with two unknowns. So usually for x and y, or a and b, just two unknown variables. In this one, we're going to take you through three unknowns, and then one linear and one quadratic. What do you do there? Okay, so introduction. In the last lesson, we looked at systems of simultaneous equations using two methods, both the elimination and substitution, like I said. We're going to start with the three unknowns, and you should know how to use the elimination method to solve the three unknowns. There are many ways to solve simultaneous equations. These aren't certainly by any means the only way to do them, but this is the way that I'm going to teach you certainly how to do it. So solving equations with three unknowns builds on the foundations we had beforehand. We're going to build on the way that we eliminated. First thing to know is if you've got three unknowns, you need three equations to solve it. Similarly, if you had four unknowns, you'd need four equations. So, no better way to do this than to show you an example. And it is definitely basis on the elimination methods with two unknowns, and you'll just see that there's pretty much just a bit more work to it more than anything else. So, we've got three equations we've got of x plus 2y plus z equals 8. X minus y plus 2z equals 5, and 2x plus y minus z equals 1. First thing we're going to do is number them like before, so we can keep ourselves organised and keep track of what's what. So I'm going to number them 1, 2, and 3. And what we're going to do, we're going to take these equations in pairs. So we're going to take two at a time and eliminate one of the unknowns. If we can eliminate one of the unknowns, we'll end up with equations with two unknowns, and we already know how to solve those. A lot of words into explaining what that is, but hopefully it'll make sense after a while. So the first two I'm going to take are going to be, well, first thing I'll look at before I decide what I'm going to look at, I'm going to look at the coefficients, just like I kind of got you to do before with the simultaneous equations. So the coefficients are the numbers that go with the variables that I have. So we've got 1x, 2y, and 1z, so 1, 2, 1, that should be, run me around, 1 minus 1, 2, 1 minus 1, 2, and 2, 1 minus 1 is there. You can decide which one you want to do. But for me, the easiest one to eliminate there is the x. That's ones that are going to be the easiest to manipulate. We've got two coefficients that are the same, and one that's just doubled all the other ones. So we're going to eliminate the x terms, the 1, 1, and using the 1, 1, and 2. So I'm going to take the first two equations together, 1 being x plus 2y plus z equals 8, and equation 2 being x minus y plus 2z equals 5. The x terms are both the same sign, so we're going to subtract, take one equation away from the other one, and the x's will cancel. So x minus x gives me nothing. 2y minus y gives me plus 3y, and plus z minus 2z gives me minus z. 8 minus 5 gives me 3. And I get a new equation, which I'll call equation 4 if I want, of 3y minus z equals 3. So we just have two unknowns in that little new equation. One must take two different equations, so we used 1 and 2 there. So I'll use another 2. In this case, I'm going to take 1 and 3. And you'll see that the coefficient of the x is 1, the coefficient of the x is 2 here. So I'm going to have to multiply the first equation by 2, so that these two numbers are the same, so the coefficients are the same. When I multiply the x plus 2y plus z equals 8 by 2, the whole way across, I'll get that to be 2x plus 4y plus 2z equals 16, and I'm going to copy the other one across. Just like before, the x terms are the exact same sign, 2x plus 2x and plus x, so we're going to subtract to get our new equation. So if 2x minus 2x is nothing, 4y minus y is 3y, 2z minus z, always be careful of that. The take away minus gives us a plus, gives us plus 3z, and 16 take away 1 gives us 15. this gives us another equation just with y and z. Now the question is just like before with our two unknowns. With two equations with two unknowns, we're going to just solve it like the last lesson. So with 3y plus 3z equals 15, 3y minus z equals 3. Well, they're already the same coefficient, same number. They're both the same sign. We're going to subtract again. 3y minus 3y is nothing. 3z minus z is 4z. And 15 minus 3 is 12. 4z equals 12. So z is equal to 3. And that's our first value that we found out. Once we've got that, we can find the other values by substituting into the other equations. So if we know z is equal to 3, we can use one of these two new equations just to find out what y is. So I'm going to substitute z equals to 3 in the equation 4, which is the top one here. So that would be, the second one here. The 3y minus z would equal to 3. I'm going to replace the z with the 3. So 3y minus 3 equals 3. Rearrange, and that gives me 3y equals 6. And y is equal to 2. That's our second value. And lastly, we're going to substitute y equal to 2 and z equal to 3 in the equation 1, which was x plus 2y plus z equals 8. Substitute the y to be 2, the z equal to 3. That gives me x plus 4 plus 3 equals 8. That's x plus 7 equals 8. What plus 7 gives me 8. 1 plus 7, so x equals to 1. And there are three answers. Remember, you can check. We used the first equation 1. You can use equation 2 and 3 to check your three values in the other equations to see if they work, but they do. And that is how you use the elimination method to solve three unknowns. This process is quite long, as you can see. It's taken me a number of slides to go through, but if you keep your work organised, and that's one of the reasons that I number my equations as I'm going along, you'll find that with practice, this will become second nature because it just builds on what you did from the last lesson, which most people found quite straightforward. And that's how to solve simultaneous equations with three unknowns. What's next? So that's one type of problem out of the way. We're going to turn our attention towards the second objective, which was to solve simultaneous equations with one linear and one quadratic. And what you'll need to know for this is the substitution method for solving simultaneous equations with two unknowns. Again, not the only way to solve this at all, but if people are looking for a consistent method to solve these equations, then this is the way that I'm going to teach. So linear equations form straight lines. You'll have seen those when we did coordinate geometry, or when we do coordinate geometry. And usually have the form ax plus by equals c, or y equals mx plus c, if you remember from GCSE. And quadratics, we've already done in the course, are of the form y equals ax squared plus bx plus c. So they have a squared term in them. So we'll have single x and a squared term. So we're going to solve the simultaneous equations for x and y. So we're looking for the values that for x and y that satisfy x plus 3 equals 5 and x plus y squared equals 5. The first thing we're going to do is number them 1 and 2, just like we did before. Now, we're going to take the linear equation, because it's the simpler one, and rearrange it so that one of the unknowns is the subject of the formula. Now, I would suggest when you're looking at your unknown, or your quadratic equation here in the second part here, we have one of the terms that's still linear. I would replace that one if I could. If you replace this one, you're going to have to multiply it out per brackets. I'll show you that in class, why that can get a little messy, but it should also work. Okay, so we're going to replace that unknown in the quadratic by substituting the linear expression in its place, just like we did the substitution method for two unknowns. So rearranging the x plus y equals 3 for x, we'll get x equals 3 minus y. And I've called that 1 dash or whatever because that is just a reform of that first equation. So we're going to take that and we're going to substitute for the x with the 3 minus y. So we've got x was equal to 3 minus y, or x was exactly the same as 3 minus y. So I'm going to replace the x here with 3 minus y. I've got 3 minus y plus y squared equals 5. I'm going to multiply that out and rearrange so that it's got a y squared term at the front, then the y term, then the number. So it'll give me y squared minus y plus 3 equals 5. And to solve quadratics, we need it equal to 0. So I'm going to move the plus 5 over here, and that'll give me y squared minus y minus 2 equals naught. We can factorize that. If you want to take the time to do it, you can, but that gives a y minus 2 and y plus 1 equals naught, and that gives me y equals 2 and y equals minus 1. Now, you'll notice that there are two solutions there. We need to find our x values that go with those y solutions. I'll take you through why there's two solutions in a second, but it is not uncommon for you to get two values for your y and two values for your x. You won't always, but it's quite common. We're going to use the linear equation. We're going to substitute these numbers back into the linear equation, x plus y equals 3. To work out the x values, you can use the quadratic, but the numbers are just a bit more messy, and it's easier. We always like the shortest route to a solution in maths, so we'll use the linear equation. So we're going to substitute y equal to 2 and y equal to minus 1, and I'll follow those down. So x plus y equals 3 was our original. We're going to place the y with 2, the y with minus 1 to see what we get. So if something plus 2 equals 3, something minus 1 equals 3, that gives me x equals to 1, x equals to 4. And what we get are coordinate pairs. So the 1 goes with the 2, that gives me a coordinate of x equal to 1, y equal to 2, or 1, 2, and x equal to 4, and y equal to minus 1, or 4 minus 1. And I'll show you what this looks like as part of a graph. So we'll have got our solutions, but I'll show you why this makes sense. Two solutions y. I'm going to plot. You can plot them yourself on Desmos.com and see if you can make this. See if it makes any sense. But I'll show you what it looks like here. Okay. So this is a graph. This is what the x plus y equals 3 line looks like, and this is what x plus y squared equals to 5 looks like. And you'll see that the line cuts the curve at 2 points. So when you're getting simultaneous equations, as I explained to you last lesson, it's about the points that the two lines intersect, or the bits that they cross, or the values for x and y that are the same for both graphs. So the linear line cuts the quadratic in two distinct places. These are the coordinates that we just calculated, and as you can see, 1, 2 is 1, 2 is this one up here, and 4 minus 1 is this one down here. We may not always get 2 points, but this should explain why we get two sets of solutions. And we'll investigate this more in the next topic, the 1.4, start of coordinate geometry. Next time on that coordinate geometry, we're going to look at the equation of a line and midpoint. We're going to follow on from that by looking at parallel and perpendicular lines and the intersection of lines. Our objectives for today's lesson were solving simultaneous equations with 3 unknowns using the elimination method, and solve simultaneous equations with 1 linear and 1 quadratic using the substitution method. And hopefully we have done both of those. Practice, practice, practice. There's exercises, solutions, quizzes and downloads and notes on the subject. Go to flipmath.co.uk and search for simultaneous equations. Feedback and all resources sent to flipmath. And good luck with your work. I'll catch you next time. Thanks for watching. Cheerio.